quadratics and factoring. We're getting into imaginary and complex numbers. And so we're going to start with what is I. Before we get into complex numbers, we've got to talk about I. I had a student in Algebra 1 several years ago. Always remember Travis. When are we going to talk about imaginary numbers? When are we going to talk about imaginary numbers? Well, today is the day for us. So I want you to think about I in two ways. Both of these facts are important. Some people latch onto one better and some people latch onto the other better. So I want you to think about both of these facts as being very important. One's more technically definitional, but whichever one you get should help you get the other one, I hope. Okay, so two things to remember about I. So I is going to be an imaginary number. It works like a variable for a lot of our purposes. We can add them, we can multiply them, we can divide them. And it doesn't have a value in exactly the same way that pi does. We're going to learn about e later in the year. It's not exactly like that. It was kind of invented to let people go farther with things. So I mentioned when we watched some videos about parabolas and it was saying how there was no solution. Well, in Algebra 1, sometimes we had no solution because it was no real number solution. And this is where imaginary numbers come in, complex numbers. So two things to remember are that I is equal to the square root of -1. So in the past, we've never been able to deal with negatives under the square root symbol. Now we can. We can say that square root of -1 equals I, and we agree on that. And because of that fact, or vice versa, whichever way you want to think about it, I squared is -1. Why is I squared -1? Well, if I have I times I, that's square root of -1 times square root of -1, and whenever we have a square root multiplied by itself, off to the side here I'll do a little example, right? What's the square root of 10 times the square root of 10? Well, that's the square root of 100. What's the square root of 100? 10, plain old 10. So whenever you square something that's a radical, you get the thing without the radical. So that's why this is true. So that's the one big fact you have to remember, and that's the other big fact you have to remember. Some people are better at remembering one, some people are better at remembering the other. Latch onto whichever one you need primarily and let it help you get the second one. What we're going to need to do is we're going to need to be able to state a value for I to any power. And it sounds tricky, but it's actually really easy and kind of fun. So let's start with I squared. I like to start with I squared just because I get I squared the best. I can remember that I squared equals -1 most easily because we actually use I squared quite a bit. So I squared is -1. We're just going to take that as our definition and we're going to use that. Well, if I take the square root of that, I'm going to get I to the first power. Okay, well, what if I multiply I times I squared? Okay, I'm going to do this off to the side in some other color. I times I squared. Well, I is just I, and I squared is -1, so that's -I. So I to the third is -I. And let's back up one before this. What's anything to the 0 power? I hope we've talked about this in class at some point this year. I to the 0 power. Well, anything to the 0 power is plain old 1. 10 to the 0 power is 1. X to the 0 power is 1. 3700 to the 0 power is 1. Anything to the 0 power is 1. But this is really important to know. This is what you need to know to be able to figure out any power of I. So how does that work to help us figure out other powers of I? Erase this guy over here. So I don't want to change screens. I want to keep that same screen up. So if I give you, if we know that I to the third is -1, what's I to the fourth? Well, I to the fourth we can think of as I squared times I squared. What's I squared times I squared? -1 times -1, that's 1. I to the fifth, we can think of that as I times I to the fourth, which is 1 times I, which is I. I to the sixth, I could think of as, let's kind of get those out of the way. I could think of it as I to the first times I to the fifth, or I to the fourth times I to the second. I like I to the fourth times I to the second. I could think of it as I to the third times I to the third. But anyway, remember, if we add the exponents, we get 6. What's I to the fourth? Very easy. What's I to the second? Very easy. So what's I to the sixth? -1. I to the seventh. I to the seventh is I times I to the sixth. I to the sixth is -1 times I, so it's -I. What do you notice here? This looks very similar to this. Same, 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 same. That pattern continues. I just copied that same little chart over onto a clean slide here. You're going to need to be able to answer the value of any power of I. So, how do I know any power of I? Ask yourself, is the number a multiple of 4? If it's a multiple of 4, your answer is 1. So I to the 8th, 1. I to the 12th, 1. I to the 16th, 1. I to the 20th, 1. I to the 100th, 1. I to the 400th, 1. I to the 116th, 1. Anything you can divide evenly by 4, it's going to be 1. So if it's a multiple of 4, it's going to be 1. Is it even, but not a multiple of 4? So I to the second, I to the sixth, I to the 10th, I to the 14th, I to the 18th, I to the 22nd. All those numbers are divisible by 2, but not 4. All those guys are going to be -1. And so I use those two to help me figure out, where I'm at. The odd numbers are a little harder for me. I kind of have to back into it. So I start with where it is in relation to a multiple of 4. If it's 1 less than, a multiple of 4, then it's going to be -I. If it's 1 more than a multiple of 4, then it's going to be plain old I. So let's test that out. I to the 35th. Okay, it's not even, so I have to think about it a little harder. 35 is 1 less than 36. If I to the 36th is 1, then I to the 35th is -I. It's just above it in that cycle. How about I to the 101? Okay, well, I to the 100 is divisible by 4, so that's 1. I to the 101 is 1 after that, so it's I. Okay, so play around with that a little bit. So we'll simplify a couple negative radicals. how about negative radical 27? Okay, well, I want you to think about it's always -1 times radical whatever. When you have a negative radical, just think of it as, oh, there's an I, and then the rest of it is just the same what it's always been, so 3 radical 3. But we tend to put it in this order, 3I, and then radical 3. Let's do another one. Square root of negative 75. Okay, so 75, I'll do a tree on this one just because we haven't done one for a while. 3 times 25. Now if I recognize 25 is a perfect square, I already know it's going to be a 5 I pull out, but I'll do the detail on this one. So think of it, it's radical 1 times radical 75. This is my I. Now I'm just simplifying regular radical 75. So I have 3 times 5 times 5. I've got a pair of 5s. So a 5 will come out, and it'll be 5I radical 3. Okay, so a couple little examples there. If it's something that can't be simplified, negative 37. 37 is a prime number. Nothing can come out. Radical -1 times radical 37. I can't do anything with radical 37. So it's just I radical 37. The I can still come out. 37 just stuck the way it is. No square factors in it. It doesn't have to be prime. It's just that there's no square factors.